Section 3.4 explores automation and tools for patch management. At scale, manual effort is no longer enough. In environments with hundreds or thousands of systems, human administrators can't keep up with the volume or speed of updates. Automation becomes the force multiplier that makes patching feasible. By standardizing tasks, reducing errors, and accelerating timelines, automation frees IT and security teams to focus on strategy instead of repetitive execution. Manual patching is slow, inconsistent, and often leaves gaps. One system may be updated while another is missed. Rollouts get delayed as administrators juggle competing tasks. Automation solves these challenges by applying updates systematically across the environment. The benefits are clear: speed, with updates distributed in hours instead of weeks; consistency, with systems patched uniformly; fewer errors thanks to reduced manual work; scalability across hundreds or thousands of devices; and built-in reporting dashboards that make compliance easier to track. With automation, patching moves from an overwhelming chore to a manageable, repeatable process. In Windows environments, Microsoft provides several automation tools to streamline patching. WSUS, or Windows Server Update Services, is a free option that lets administrators approve, schedule, and deploy Microsoft updates across the enterprise. For larger organizations, System Center Configuration Manager, often called SCCM or Config MGR, offers a more robust platform for managing not just patches, but also software deployment and configuration. Intune provides a modern, cloud-native approach, covering Windows as well as macOS, iOS, and Android devices. Together, these tools allow organizations to centralize patching, define policies, and automate deployments across thousands of endpoints. Linux and Unix systems rely heavily on package managers to automate patching. In Red Hat-based distributions, YUM and DNF are commonly used to apply updates across servers. Debian-based distributions like Ubuntu use APT, while enterprise platforms such as Landscape for Ubuntu and Red Hat Satellite provide automation at scale with reporting features. Many organizations also integrate patching into scripts or configuration management tools like Ansible or Puppet. This ensures patches are deployed consistently across entire clusters of servers, reducing manual effort and minimizing gaps. In cloud and hybrid environments, automation isn't optional, it's built in. Providers deliver patch orchestration that integrates with virtual machine and service management. AWS offers Systems Manager Patch Manager, which automates patching for EC2 instances and provides compliance dashboards. Azure Update Management enables scheduling, deployment, and reporting across Azure VMs, as well as hybrid servers. Google Cloud provides OS Patch Management for automated rollout on Compute Engine VMs. Because cloud systems are highly dynamic, automation ensures that newly provisioned instances are patched immediately and consistently, reducing gaps and manual work. For organizations using DevOps or infrastructure as code, patching can be built directly into automated workflows. Tools like Ansible, Puppet, and Chef automate not just configuration, but also patch deployment. CI/CD pipelines can include patches in the deployment process so that every new system comes online with the latest updates already applied. In containerized environments like Docker and Kubernetes, automation ensures that images are updated, rebuilt, and redeployed consistently across clusters. This integration keeps patching continuous, reliable, and aligned with modern DevOps practices. Automation in patch management goes beyond simply applying updates. It also delivers visibility. Modern tools provide dashboards that track compliance, highlight exceptions, and measure mean time to patch. Some platforms integrate with SIEMs like Splunk or with service management tools like ServiceNow, linking patch data to incident and workflow tracking. This visibility is critical, not only for improving operations, but also for demonstrating compliance and accountability to auditors and executives. While automation is powerful, it isn't a silver bullet. Automated patch deployments can still cause outages if updates aren't tested properly. Worse, a misconfigured automation process can spread mistakes across the environment faster than any manual error. That's why organizations must balance automation with strong testing, rollback planning, and governance. Automation works best when paired with these safeguards to ensure stability and trust in the process. Section 3.4 showed how automation transforms patch management from an overwhelming manual task into a scalable, reliable process. We explored tools for Windows, Linux, and cloud environments, as well as DevOps pipelines and container workflows. Automation brings major benefits: speed, consistency, reduced errors, scalability, and visibility through dashboards and compliance reporting. But we also saw that automation isn't a silver bullet. Without proper testing, rollback planning, and governance, automated processes can just as easily cause outages or spread errors quickly. The key takeaway is that automation, when paired with safeguards, enables organizations to patch at scale with confidence, while maintaining stability and compliance. Section 3.5 focuses on reporting and metrics in patch management. Applying patches behind the scenes is critical, but without measurement, organizations can't prove they are truly reducing risk. Metrics provide the evidence that patching is effective, expose gaps that need attention, and demonstrate accountability to executives, regulators, and customers. In this section, we'll explore 3 fundamental measures: mean time to patch, compliance rates, and coverage percentages. Mean time to patch, or MTTP, measures the average number of days between when a patch is released and when it's deployed in the organization. It's a leading indicator of patching agility. The shorter the MTTP for critical vulnerabilities, the lower the window of exposure to attackers. Since exploits often appear within days of disclosure, reducing MTTP directly reduces risk. Organizations usually set targets by severity. For example, 7 days for critical vulnerabilities, 14 to 30 days for high, and 60 to 90 days for medium or low. The challenge is that MTTP can be skewed by exceptions or legacy systems, so it must be tracked carefully across different asset classes. Compliance rates measure how many systems are patched within defined service level agreements, or SLAs. Put simply, this metric answers the question: are we meeting our own patching standards? Regulators, auditors, and insurers often want this proof. For example, PCI DSS requires critical patches within 30 days. A common policy might set the goal at 95% of critical systems patched within 7 days. Compliance is then calculated as the number of compliant systems divided by the total number of systems multiplied by 100. High compliance rates reassure executives and auditors that risk is being managed, while low rates highlight resource or process gaps that need attention. Coverage measures how much of the organization's environment is even included in the patch management program. Without strong coverage, compliance metrics can be misleading. For example, an organization may report 95% compliance, but if only 70% of systems are in scope, nearly a third of the environment remains unmanaged. Coverage ensures that patching applies across all asset types, not just a subset. Key measures include the percentage of endpoints, servers, cloud systems, IoT, and mobile devices included. The goal is high coverage across diverse environments, supported by a process that quickly brings shadow IT and new assets into scope. Each metric, MTTP, compliance, and coverage, tells part of the story, but together they provide a full view of patch program health. MTTP shows how quickly vulnerabilities are closed. Compliance measures whether policies are being followed. Coverage reveals whether the scope is sufficient. By tracking all 3 together, organizations avoid blind spots. For example, a dashboard that shows low MTTP but poor coverage indicates that patches are being applied quickly, but large parts of the environment remain outside the program. Metrics only have impact if they're tailored to the audience. Executives and boards want high-level summaries, like 98% of critical systems patched within SLA, usually presented through dashboards and trend lines. Technical teams need the details, breakdowns by asset type, owner, or system, to know where action is required, such as which servers failed compliance this week. Regulators and auditors expect documented evidence, including patch logs, exception records, and proof of SLA adherence. Matching the level of detail to the audience ensures that patching metrics drive both action and accountability. Metrics are powerful, but they can also mislead if used incorrectly. Vanity metrics, like the total number of patches applied, sound impressive, but don't reflect real risk reduction. Exceptions and legacy systems can distort averages, making results look better than they actually are. That's why reporting must always connect metrics back to outcomes. How much risk is being reduced, not just how much activity is happening. Section 3.5 highlighted the role of reporting and metrics in proving patch program effectiveness. We explored 3 core measures: mean time to patch, which tracks how quickly vulnerabilities are closed; compliance rates, which show whether patching SLAs are being met; and coverage, which ensures all assets are in scope. Together, these metrics provide a holistic view, but they must be tailored to their audience. Executives need high-level summaries, technical teams need detailed breakdowns, and auditors expect documented evidence. Finally, we saw that metrics have limitations. Averages can be distorted, and vanity counts don't prove risk reduction. The key takeaway is that patch metrics only matter when they demonstrate real-world outcomes: closing vulnerabilities, reducing exposure, and maintaining trust. Patch management does not exist in a vacuum. Every update you apply is, at its core, a change to a live production system. That makes patching inseparable from an organization's broader change management process. Both disciplines aim to improve systems while reducing risk and disruption. Without structured change management, even the most well-intentioned security patch can cause instability, downtime, or even compliance violations. This section explores how patch management and change management intersect, and why aligning the two is critical for both security and operational stability. Successful patch management depends on following core elements of change management. First, approval workflows ensure that critical patches, especially on high-value systems, are reviewed and authorized before deployment. Documentation is equally important, capturing when patches were applied, their expected impact, and the rollback steps if needed. Clear communication keeps stakeholders informed about potential downtime or risks in advance. Rollback planning provides a safety net, with procedures ready to restore service quickly if something goes wrong. Finally, a post-implementation review confirms stability and records lessons learned for future improvements. Together, these steps bring discipline and resilience to the patching process. In regulated industries, the link between patching and change management takes on even greater importance. Auditors and regulators don't just want to see that patches were applied. They expect evidence that updates followed established procedures. Well-documented change management records provide that accountability and traceability. In practice, mature organizations go further by integrating patch management directly into their change management platforms, often through shared ticketing systems or automated workflows. This integration not only streamlines the process, but also ensures visibility across IT, security, and compliance teams, reinforcing both efficiency and trust. In many organizations, patching is tightly embedded into the change management process using IT service management platforms. Groups of patches are often bundled into a standard change cycle to reduce overhead and keep the process consistent. When a new patch is released, a change ticket may be automatically generated in tools like ServiceNow or Jira. That ticket captures severity, impacted assets, deployment timing, and rollback plans. It then moves through approval workflows so both business and technical stakeholders can review before rollout. Once the patch is applied, the same record is updated with verification results and compliance status. This creates a single source of truth for IT and audit teams, ensuring standardization, visibility, and accountability across the enterprise. In Section 3.6, we see how patching and change management work together to deliver both speed and stability. Security updates can be deployed quickly to reduce risk while still maintaining governance, documentation, and accountability. This balance reassures executives, auditors, and users that improvements are made in a controlled and sustainable way. A mature program does not view patching as routine background maintenance. It treats it as a structured change process that builds resilience and trust across the organization. Section 3 walked us through the patching process from start to finish. We began with the 7-stage lifecycle, from discovery through documentation and reporting, showing how patching becomes a structured, repeatable discipline. We then explored testing, where smoke testing and rollback planning act as the guardrails that keep patching safe. Next, we looked at exceptions and workarounds, recognizing that some systems can't be patched immediately and must be managed through governance and compensating controls. Automation was another key theme, demonstrating how tools across Windows, Linux, cloud, and DevOps environments scale patching while providing visibility, though always with limits that require testing and oversight. Finally, we covered reporting and metrics, focusing on MTTP, compliance, and coverage as the measures that prove effectiveness and guide improvement. The key takeaway is that patch management is not a single act, but a life cycle supported by testing, governance, automation, and metrics, turning patching into a repeatable process that balances speed, stability, and accountability.